model. Okay, so electron is embedded in it and there is a positive sphere. The negative and positive charge are equal in magnitude, so the overall atom was electrically neutral. Negative and positive charges are equal in magnitude and the overall atom is electrically neutral. It is not the charged species. Okay, because Thomson has no idea about any other atom than the proton and electron. So he thought, okay, fine, proton and electron are like cannot be in the one place, so they remain in a dispersed manner. So positive charge on atom was uniformly distributed according to him, but that was not the case. So, but we will discuss what type of model it looks like. You can see here, this is the electron, these are the protons here. He said the sphere is made up of positive sphere is positive sphere. Okay, these are the electrons, that is like it is like a plum, and negative is the puddings. So here you see it looks like a watermelon thing, right? I think you all have learned this earlier also. Could I move to next thing? Yes, no? So array say yes or no? Yes, yes, no one is replying. Guys, what happened? Do you have any doubt in this? No? Okay, this is the plum pudding model. So, but there is a limitation of Thomson model. Can anyone tell me what is the limitation? I think you must have learned earlier also this part. What was the limitation of Thomson model? Yes, Pratik, tell me. Yes, yes, fast. What is the limitation of Thomson model? Anyone? Very good. It could not explain the scattering experiment. Scattering experiment means, like, there is one experiment later we will see, that scattering experiment, or Thomson Rutherford alpha scattering experiment, we will see it could not explain that part. This is the one thing. Second, the second reason is, okay, scattering experiment was not able to perform, and it does not tell about the stability of an atom. Like if positive and negative are uniformly distributed, it does not tell much about the stability of atom. According to this model, atom should not be stable. Okay, so Thomson model of atom is entirely theoretical, has had no practical approach. Guys, still here? Any doubt? Yes or no? I am moving to the next atomic model, which was the Rutherford's model. Okay, so if anyone has any doubt till here, then ask. No doubts? If you have no doubt, then let us move to the next part. Just give me 1 second. Okay, so I hope you can see my screen now. Here is the okay. So here we discuss about the Thomson model. Now, after Thomson model, Rutherford did one experiment. This is called as Rutherford alpha scattering experiment. What he did, he took a radioactive atom. Did we discuss Rutherford alpha scattering experiment? Not yet, right? Yes or no? Now, what he did, he took a source of alpha particles. Alpha particles are helium 2 plus ion. He took the source of alpha particles that were having a very high speed, and it was bombarded. The gold foil. This gold foil was bombarded with the alpha particle, fast moving alpha particle. So what happened? Most of the alpha particle, when the gold foil was bombarded, most of the alpha particle passed undeflected. Till here, any doubt? Most of the alpha particle passed undeflected, right? Why? And he took a very thin gold foil, very thin. Most of the alpha particle went undeflected. Few got diverted like this. Few got diverted like this, right? Okay, just a minute. Okay, few got diverted like this, right? Um, you can see this. When alpha particle were bombarded, most of the alpha particle went undeflected and goes in a straight path. Few got diverted in some angle. You can see that few of the alpha particle got diverted, and he has kept the ZNS screen. This is a zinc sulfide screen here. This screen is nothing but zinc sulfide screen. So when the alpha particle hits this surface, it glows for a moment. So most of the ray passed undeflected, few got deflected, and they also give the direction, means some glow. This means very few rays are deflecting, and I want to tell you, out of 220,000 rays, one ray is deflecting back by 180-degree in the original path itself from which it came. Okay, so that is the alpha scattering experiment. So narrow beam of alpha particle was allowed to fall on the very thin gold foil of thickness of order this centimeter. A very thin gold foil was taken, and the subsequent path of this particle were determined with the help of zinc sulfide fluorescent screen. I told you a screen was taken, which is a zinc sulfide screen. Now we have seen the experiment. The zinc sulfide screen gives off a visible flash of light when struck by alpha particle. I told you in last class also, zinc sulfide has a property to show the glow when any particle hits that zinc sulfide screen. So ZNS has a remarkable property of converting kinetic energy of particle into visible light. If any particle hits the zinc sulfide, it convert into visible light. Alpha particle was used because they are relatively heavy. Okay, why alpha particle was used? Their mass is little heavy, so it was used, and resulting in high momentum. Guys, could I move to next slide? Yes or no? Could I move to next slide? Yes? Okay, copy it fast. Once you finish it, write done. Okay, fine. Aditya, done? Okay, fine. Now, so this was the alpha scattering experiment. Tell me answer of these questions quickly. What is answer for this? B or none of these? B or none of this? Hey, helium 2 plus is the answer now, right? So answer should be none of these, right? Yes or no? Arey my dear, answer is B only, not none of these. Because helium 2 plus is nothing but helium nucleus only. Because helium neutral, helium has 2 electron. So if you remove 2 electron, it becomes helium 2 plus. That's it. Got it? So it is neutral species. Sorry, it is nuclei only. Helium nuclei. I'm moving to the next thing. Okay, alpha particle is a helium nuclei. Please remember this. Okay, next. You can see this. Just a minute. Um, you can see the Rutherford alpha scattering experiment. Mostly the rays are going straight. This red particle is the particle through which rays are deflecting back to some angle, okay, like that. So majority of alpha particle pass straight through the gold strip with little or no deflection. This is one of the observation of Rutherford experiment. Understood? Most of the rays passed undeflected. Tell me, if most of the rays passed undeflected, what does it tell? If most of the rays passed undeflected, what does this tells? Very good, Saket. Anyone else? What does it tell? Just a minute. Most of the rays passed undeflected. What does this tell? That most of the space is empty in an atom. Understood? Most of the space is empty. Okay, fine. So have you written this? Very good, Kshitij, Arthur, Naren. Any doubt? Any doubt? So majority of alpha particles pass straight and there no deflection. I'm moving to the next slide. Very good, Krish. Correct answer. Some alpha particles were deflected from their path and diverged. Any doubt in this? Any doubt in this, guys? Any doubt? No one? Okay, fine. I'm moving to the next slide then. Just a minute. Just a minute. Okay, fine. Next thing is, few alpha particles are deflected back through the angles greater than 90 degree. You can see here some alpha particles deflected by greater than 90 degree. Any doubt? Any doubt? So what he concluded that most of the rays passed undeflected and few are deflecting by greater than 90 degree. This means deflection is being caused, and deflection is caused only if there is a positive particle at the center. Because positive rays are getting deflected means definitely there will be a positive particle at center. That is why it is the positive ray is getting deflected. Positive can deflect the positive thing, right? So that is why there is a deflection. Some alpha particles are deflected from their path and diverge. Okay, some alpha particles are deflected from their path and diverge, that I already explained you. So what he concluded that most of the space is empty and there is a positive charge present at the center of the atom, because from there only deflection is coming. Guys, can I move to next slide? Yes, no? Okay, next. Yes, what is answer for this? Most of the alpha particle pass straight through the metal. Understood? So this means there is an empty space. I am moving to the next slide. Few alpha particles are deflected, indicates that there is a positively charged center. Got it? Because alpha is a positively charged, it is undergoing deflection, means positive is present at the center. Guys, any doubt?
So 1 minute, so just taking the second point down.
Done?
So 1 second, so last one. So please could you explain the second point again, sir?
Second point. So few alpha particles are deflected as large angle indicates that positive part is there and means, where is the positive part present in the atom? That tells because alpha particles are deflected by large angle. Some alpha particles deflected by large angle. This means positive particle is present at the center, which is
Yes, so nucleus.
heavily positive. That is the, and deflection is very few. Deflection means very small area it is covering. Understood?
Got it, sir. Thank you, sir.
Okay, guys. Should I tell? So now only 1 out of 20,000 are deflected by 180 degree. Any doubt in this? No, yes. Okay, fine. The next is, okay, so indicating that volume occupied by this heavy positively charged body is very small in comparison to total volume of atom. Guys, any doubt in this? Any doubt in this? Yes or no? Okay, fine. I'm moving to the next thing then. Total mass of atom is present in a very small region of an atom, and that was the first time someone gave the name of that center thing as a nucleus. Guys, clear? Yes or no? This positive center was called as nucleus. Got it? Any doubt? Okay. Next is, the size of nucleus is very small in comparison to size of atom. It is same like, you know, size of atom is very small and a size of nucleus is very small. It is like, you can compare it like a football in a football ground. Similarly, the nucleus size is that much small in an atom. Understood? The electrons equal in the number to that of nuclear positive charge. I told you, because new positive charge is there in the nucleus, and that should be balanced with the electrons only. So electrons are equal in number than the positive charge, and that revolve around the nucleus with high speed in circular orbit. Guys, if you have any doubt, then please ask. Any doubt?
Sir, I got disconnected. What do we do after Rutherford's model?
No, it is, the Rutherford model is still going on. Means after Rutherford, what we will do? You are asking.
Oh, so
Huh?
like I got disconnected when we like just started Rutherford. So this is still
No,
going
it's
on.
a scattering experiment only I am discussing.
Oh, okay, so okay.
Okay, next. Can I move to next thing? Okay. So here, electrons and the nucleus are held together by electrostatic force of attraction. No. Actually, electrons and alpha particles have a huge difference in mass. Alpha particle is very, very heavy as compared to electron mass. Because alpha is 4, even like means it is 4 times heavier than proton, and protons is 2000 times heavier than electron. So it is almost 8000 times heavier. So alpha particle does not get deflected by the electrons. Understood? And second, it is negatively charged. So there is no point of deflection. Understood? Done? Next. Now guys, nucleus is very, very small, heavily positively charged part of an atom. This is present at the center. All positive part of the atom are present in the nucleus. Guys, because I told you that it will get deflected, so entire positive charge will present in the nucleus only. Nucleus contain. Now what happens? You know, the problem, as I already explained you, neutron was discovered by, earlier it was not discovered before Rutherford, after Rutherford model. In the Rutherford model, what he said, he told about only protons. After that, neutron was discovered later. So in the nucleus we have neutron and proton both. Though Rutherford has no idea what the neutron is, but later Chadwick discovered this neutron thing also. So in the nucleus you have two things, neutron and proton. So collectively they are called as nucleons. Any doubt? Any doubt, guys? Any doubt? Collectively they are called as nucleons. That is neutron plus proton. Okay, is the mass of an atom because of these two things? Is the mass of an atom is because of these two things? Yes? Yes. Mass of the atom. Very good, Naren, Nihal. Correct answer. Even Pratik. Why? Why it is correct? Because yes, mass of electron is negligible as compared to mass of proton and neutron. That is why overall atom mass will be decided by mostly by neutron and proton. So size of nucleus is measured. Okay, so now see what is the next point. The next point is they are saying that size of a nucleus is measured in Fermi meter. 1 Fermi is 10 power minus 15 because size of an radius of nucleus is given by R equals to R naught A to the power 1 by 3 centimeter. Please write this formula, a very important formula for solving numericals. Radius of any nucleus was calculated and it came out like this. Understood?
So could you please explain that formula again? R equals R naught A to power 1.
This is the radius of nucleus formula. R naught is a constant here. This is the value of constant. Truly speaking, it is they have written this little wide range. You can write like this also 1.3 to 1.44. This is little narrow range. 1.32 to 1.44 into 10 power minus 13 centimeter. What this range is about? This range is nothing but R naught value. R naught is a constant. Okay. R is the radius of any nucleus. A is the mass number of the nucleus. Mass number I explained in last class. It is nothing but neutron plus proton. Got it? Yes or no?
Yes, sir. Yes, sir.
Now,
Thank
what
you,
is
sir.
R naught? If I put A1, I will get R naught. Yes or no? If I put A1, I will get R naught. A is 1 for which element? Mass number 1. Hydrogen. So R naught represents the, you can see here, if I put A1, R become R naught. This means radius of a nucleus become R naught. That is nothing but radius of nucleus of hydrogen atom. Understood? Radius of nucleus of hydrogen atom. Next. So this I already explained you.
Can you go back 1 second?
Fast, right fast. Done. R is equals to R naught A to the power 1 by 3 centimeter. Next is the volume of nucleus is about 10 power minus 45 meter cube and that of atom is this much only. So nucleus radius is this, atom radius is this. And volume of nucleus is this times that of an atom. Okay, nucleus is very, very small than the atom. I already told you. It is a ball in a stadium type of thing. Understood? Understood? Okay, fine. Do this question fast. Tell me answer of this. Some are saying B, some are saying D. This B part is gamma. So correct answer is D. Very good. Raghav, Omkar, Jayan, Ritvik, Naren, Raj. So what you can say? Answer for the next question is D. Right? Any doubt in this? Because helium nuclei you put, you don't put helium atom. Helium atom is He. Helium nuclei is He2 plus. I told you, helium ion or He2 plus ion or helium nuclei, all three are same. This is gamma particle. Gamma particle is different. You will learn detail in physics. Yes. Next question. Fast. Very good. All of you have given the right answer. C for cat. Next question. Very good. Answer is C. Very good, all of you. Good. Next question. Okay, most of you have given answer B, and B is the correct answer. I am moving to the next question. So this is the limitation of Rutherford model. Now Rutherford, what he said, Rutherford model says that atoms revolves around a nucleus. That's it. He said electron is not static like what Thomson said. He said electron will revolve around the atom. That is what he gave, Rutherford model. He said proton is there at the center, electron is revolving around this. Okay, and let's say this is the entire big atom. According to him, electron is revolving around a nucleus. Okay, this is Rutherford model. But I told you according to Rutherford model, what is the drawback of Rutherford model if it is revolving around a nucleus? Tell me.
So could you please repeat the question again?
What is the limitation of Rutherford model? If atom has an electron revolving around it, what problem will happen? Actually, at that time there was a theory for Maxwell electromagnetic theory came. According to that theory, if electron is revolving around a nucleus like this, is it having acceleration? Is electron having acceleration? Yes, it has acceleration, that is a angular acceleration towards the center. Now what will happen if this charged particle is accelerating? At that time this theory came that if any charged particle accelerating, it will radiate energy. Charged particle accelerating give charged particle accelerating give radiate energy. So what will happen if this electron will radiate energy? It will start decreasing its orbital size or from where it is rotating and finally get into the cation. So according to the Rutherford theory, atom should not be stable because after some time electron should fall in the nucleus according to that theory, but it doesn't happen. This means Rutherford's theory is also wrong. Understood? Yes, very good. Sri Krish. Yes, very good. Pratik, very good. Pranav, very good. Okay. So Rutherford, you can see here electron is revolving and continuously losing energy and finally fall into the spiral center. So this is what the drawback of Rutherford model. Electron should continuously lose its energy and set a spiral motion. Have you finished writing this? Could I move to next point? Yes, no? Okay. What happens, Zayan? Writing very slow. Write fast.
So it just came on my screen.
Why? I showed it a long back. Understood? Please write done if you have finished writing this. Done? I am moving to the next slide. Yes or no? Okay. Electron will continuously radiate energy, then it's, what it is saying that if electron will continuously radiate energy, then its spectra should be continuous. If spectra should be continuous, I will explain later. Spectra in the sense, if you observe these radiations coming out from electron, okay, if you observe the radiations coming out the electron, it should be continuous. Continuous means it should have the 5-7 colors of rainbow Vibgyor thing. So if the electron was continuously radiating the energy, it will radiate all type of energy. This means it will radiate all the frequency in the spectrum. But few lines were missing in this process, means few colors were missing. This means definitely this atom is, like, you can say that, not possible, and electron will continuously and this also tells that electron is not radiating energy, because if it will radiate, it will give continuous spectrum, but practically we didn't get that continuous spectrum. This means this compound is not radiating. This means this compound is what we can say, actually the means here you can say that electron will continuously radiate, right? Sir, not radiating, continuous radiations. No, radiating in the sense of radiation energy only. If electron is releasing energy, not that radiating nuclear radiations, not that. I'm saying if electron will release the energy while it is falling down, if it is releasing energy, it should give the continuous spectra. Or if electron is radiating also, the electron will continuously radiate energy, then its spectra should be continuous. But actually, this is not the case. Atoms actually give the line spectra. What is line spectra? We will discuss in few minutes. Okay, so let us do some questions. Tell me answer of this question first. The nuclear radius of atom whose mass number is this. Consider, okay, there is one formula we have written. Apply that and tell me the answer. A naught is in the range. I gave you a new range. Use that value and tell me the answer fast. Anyone got the answer?
So R naught is in a range, right? So the answer should be in a range, right?
No. You take any value in this range. You can take the smaller
Okay.
R naught value.
Okay.
1.3 thing. As of now, I can see many of your friends have given the answer. Arthur have given the answer. Pratik, Aditya, everyone has given the answer. And your answer is right. You can see R naught a to the power 1 by 3. But how you got 5.5? Into 10 power minus 6.5 into 10 power minus 13.
Sir, isn't R not equal 1.2?
I told you the most precise is 1.3 to 1.4 thing. So they have
Okay,
taken
sir.
1.4 into 10 power minus 15 meter they have taken. We need to put in the value I showed is in centimeter. Understood? Any doubt? Any doubt?
So,
Yes.
oh, okay. That's how I'm getting a centimeter. So no, so just the exponent was different because of centimeter. I got centimeter.
They will confuse you like this. Done? Okay, next question. So now this is the next topic is distance of closest approach. Now how he got, like, see, we have got to know about the radius of an atom, of a nucleus. How he got the distance of closest approach, we will try to understand. Okay guys, so tell me one thing. Do you know what is the potential energy of a two charge system? Potential energy of two charge system. Fast.
KQ1, Q2 by R?
Okay, fine. It is K Q1 Q2 by R. Though you will learn the proof of this in physics next year. Next year in the electrostatic chapter, you will learn more about this in physics. Okay? K Q1 Q2 by R is the K Q1 Q2 by R is the, you can say, potential energy of any two charge system. Okay, fine. Tell me one thing. what will happen if I bombard the helium-2 plus ion towards the center of a nucleus? Will it stop somewhere? If I bombard the helium-2 plus ion towards the gold foil, will it stop somewhere in the path? Yes or no? Hey, no one is replying. Okay, just a minute. I'll put my laptop on charging.
So could you repeat the previous question?
I'm saying that if you put the, just 1 second. Okay, I'm saying if you bombard a helium-2 plus ion towards the center of or towards the gold foil, if you bombard, let's say this is the helium-2 plus, let's say this is the gold foil. Okay, there is a nucleus. So I will represent the nucleus like this. Let's say there is a nucleus which is having some radius. My question is, if you bombard the helium-2 plus ion, will its kinetic energy become zero somewhere when it reaches towards the nucleus? Yes or no? Very good. Anyone else? Okay, its velocity will become zero at some point. Now, guys, do you know one more concept in physics? Head-on collision. What do you mean by head-on collision? Fast. What is the head-on collision? No one? Anyone has any idea? What is the head-on collision? Okay, fine. So fine, I'll explain you. Guys, I have bombarded a alpha particle. What will happen? Because alpha particle will go towards the nucleus. Okay, it will go towards the nucleus, but it won't reach to the exact place of nucleus. At some point of time, because alpha particle is there and it is also 2 plus charge, proton is 2 plus, somewhere around here, its velocity will become zero. This is the point where it will get deflected or its velocity will become zero. So this R0 is called as distance of closest approach, or we call it as a radius of nucleus. Why I'm saying radius of nucleus? Because we don't know, it's not like one circle is like this or there the nucleus is present. I'm just assuming wherever my alpha particle will get the velocity zero, I will consider it as a radius of nucleus, because that will be the radius till where my alpha particle can reach. In other words, if you want to understand this same thing, you see alpha particles are bombarded here. When you bombard the alpha particle, this is the nucleus here. Somewhere alpha particle to get deflected from this direction like this. So this distance is called as distance of closest approach. So when the alpha particle approaches to the nucleus and make a head-on collision with the nucleus, what will happen? The particle approaches the nucleus until this expression. What does this mean? I'll explain you. What does this mean? So until it has a head-on collision, this is like, earlier my alpha particle was present here. So I would do one thing. I know that if alpha particle goes from this place and reaches to the nucleus, it will have two energies. One is the kinetic energy here, potential energy here. This is the total energy. I will see here also kinetic energy and potential energy. The interesting thing is energy remain conserved. If you apply energy conservation at point, let's say this is a point A, this is a point A, this is a point C. Energy conservation at A and C. C is what? Distance of closest approach till where alpha particle will go. And later that will be termed as radius of the nucleus. Then what is this? This is an atom, the bigger thing. So energy conservation at A and C will be how we will apply kinetic energy at position A plus potential energy at position A is equals to kinetic energy at position B plus potential energy at position B. Kinetic energy of A will be half m alpha v square. This is half m alpha v square, that is kinetic energy, plus potential energy. Now, as I already told you, potential energy here, what will be that? Actually this alpha particle is coming from infinite distance. Alpha particle is coming from infinite distance, okay, according to nucleus, very far. Or in other words, these protons have no impact on alpha particle when it is starting its journey towards the nucleus thing. So alpha particle right now has a no interaction with the proton as of now. It is moving just because of its velocity. So potential energy will be K Q1 Q2 by R will be, because R is very large and they have no interaction. R is very large, so potential energy of A will be, potential energy at A will be 0. So I will directly write 0. Now, it's not B here, it is C. Yes, what will be the kinetic energy at C? Tell me fast. Kinetic energy at C. Because particle is going to strike and change its direction, it is the distance of closest approach. After that, it can't go to the nucleus. So kinetic energy is 0. Potential energy at C point. Can I say K Q1 Q2 by R? R naught. Any doubt? Any doubt? K Q1 Q2 by R naught. Half m alpha v square, 0 plus 0. Kinetic energy at C is 0 because alpha particle will go and that is the closest approach, then it will get deflected from there. Got it? So particle will come at rest for one point of time at that deflection point. So kinetic energy will be 0. So this is the distance of closest approach. Now can I say that? Now see what I got. Okay, what is Q1 and Q2? Q1 is the charge of alpha particle. Q2 is the charge of nucleus. Yes or no? So can I say that K Q1 Q2 by R naught will be half m alpha v square? Yes or no? K Q1 Q2 by R is half m alpha v square. Can you see this? K Q1 Q2 by R. Okay, fine. They have written in Z1 and E. Okay, fine. Let me complete this. How they got Z? Let's say Q1 is the alpha particle or whatever I have took. Let's say Q1 has a atom. Q1 is caused due to Q1 is caused. Let's say there is a Z atomic number for this alpha particle. Then what will be the Q? If Z is the atomic number of the alpha particle, what will be the Q? Fast. Tell me the charge of that alpha particle. Z is the atomic number of alpha particle. What will be the charge of that alpha particle? Okay, fine. Now see, Q1 is the total charge on alpha particle, Z is atomic number, means Z are protons that are only causing charge. Can I multiply this Z with the electron? 1.66 into 10 power minus 2 minus 19. This will be the total charge. Where E is what? 1.6 into 10 power minus 19 coulomb. Any doubt?
So Q1 is an alpha particle here, right?
Yes. Okay, alpha particle
So
or whatever particle we have taken. Right now, alpha particle Z will be 2. But if you take
yes, sir. Yes, sir.
any other element also, we will write it as like Z1. If Z1 is
Correct.
the atomic number, so Z1 into charge.
Okay, got it. So thank you.
What is Q2? Z2 into E. That is the atomic number into E, because number of protons are there. Z2 into E here. Any doubt, guys? Any doubt? So can I write here half mv square is equals to k z1 z2 e square by r naught. Any doubt? Any doubt? Any doubt? Okay, fine. Did you understand this expression? Yes, yes. Radius is very high, so potential energy is almost zero. Got it? So k z1 z2 e square half mv square. Can I get the radius of nucleus by this formula? By this relationship? Yes or no? Yes or no? Can I write radius is inversely proportional to kinetic energy? Yes? Any doubt, guys? Any doubt? Any doubt? Okay. This is the explanation what I explained. What is the K value? K is 9 into 10 power 9 Newton meter square per coulomb square. This is the K value. K is 9 into 10 power 9.
So how did we get this value here?
Don't ask this. Later in physics you will learn. Just as of now, learn it. This is a constant you need to learn.
Okay.
K is a constant. This will come in next year physics chapter, electrostatic. 9 into 10 power 9 Newton meter square per coulomb square. For I told you for alpha particle Z will be 2. Z2 will be the atomic number of metal atom on which alpha particle is hitting. E is this. Now guys, interesting part is who is hitting? Alpha particle is hitting. We have written alpha particle mass like this. Can anyone explain why it is like this? I didn't understand. Write in chat box. Why mass of alpha particle is like this? Mass of helium is 4, but they have written 4 into 1.67 to 10 power minus 27. Naren, correct answer. Mass of one atom. No. Anyone else? Very good. Saket, correct answer. Okay, fine. Helium is 4 AMU. Guys, if you remember, 4 AMU is the helium mass. And this U can be written as 1 U is nothing but 1.622 into 10 power 23 gram. In kg, you can convert. So 1 U can be written in kg also. Understood? So you divide with 1 by 1000 also. So it will 1 by 1000 you divide it. So it is like into 1000 kg. So you will get 10 to the power 27 from this expression. Got it? Yes or no? Because 1 U is this much we discussed in mole concept chapter. Guys, is it clear? Could I move to next thing? Okay, then do this question. Fast. Done. Anyone done? Done? Hey, why you are taking this much time? We have already discussed this. Answer is B. We have already discussed. Radius will be inversely proportional to kinetic energy. And kinetic energy is half mv square. Radius is inversely proportional to m. Any doubt? Molecular mass. Yes or no? This means that if molecular mass is more, R naught will be R will be very less. This means distance of closest approach will be very less. In other words, alpha particle will go till maximum extent if molecule is heavy. Is it clear to everyone? We have seen 1 by m, radius is inversely proportional to 1 by m. Tell me answer of this fast. Yes, radius is inversely proportional to energy, kinetic energy. Yes, do this fast. No one got the answer.
So what is copper atomic mass, sir? So in AMU.
Copper atomic mass. How much you have taken, guys? Take 63.5. Am I audible?
Yes, sir. 63.5. Okay.
Copper mass. Anyone got the answer? Now I think I should tell you.
So here in the half mv square part, mass should be taken as mass of alpha particle, right?
Yes, because it has kinetic energy. No one else has kinetic energy.
Yes,
Fast
right.
moving alpha particle had collision with um, nucleus. GT Aditya, what's your full name? I didn't see your name in attendance thing. What's your full name?
Sir, Aditya JT.
Hey, Aditya GT Aditya only two. But
Yeah, this
there is one more Aditya. Just write yes. One more Aditya is there, right? Okay, fine. What answer you are getting?
sir, square root. I didn't see square.
Square root 5, 4, 5, 7, 3. I don't think it is right answer. How it is? That's less speed. How it is that less speed? No, Vishnu, not correct. Think again. Not correct. Hey, how very less speed? 6.2 into 10 per minus 6 meter per second. This less speed, how it will strike to the alpha gold foil and show the experiment?
So one more minute, sir. The calculation was a little long, so one last minute.
No, 10 to the power 6 is not the answer. 1 minute. Fine. One student got the right answer. Vishnu got the right answer. Very good, Vishnu. Even, no. Naren, you have made some mistake. Should I tell you how to do? Have you taken mass of alpha in kg? Mass of alpha particle in kg, because you are substituting everything. This means you need to substitute in SI unit. Done? Okay guys, I am showing you the solution now. This is the solution. Distance of closest approach r is 10 per minus 13 given. Substitute in the formula. So K value given, Z1 is atomic number 2, Z2 is atomic number 29. 2 is for helium particle, 29 is for copper. Electron is 1.6 into 10 power minus 19 coulomb. Electron charge. So mass of alpha particle will be 4. Mass of alpha particle will be what? 4 times into 1.6 into 10 power minus 27. Put every value, you will get the answer. Got it? Yes, no? Are you right? Yes or no? Okay, just check the expression. Don't solve it now. Just check the expression whether you have written right thing or not. And check your substitution. I believe you will not make mistake in solving, but at least check your substitution. Got it? Next is
So could you please tell me the final answer? I'll just make note of it and work it out later.
63.25 into 10 power 5 meter per second.
Thank you, sir.
What is the speed of light? Any idea?
So in air,
What is the speed of light? Yes, and in okay, you can consider anywhere. It is same only. Let's say in air only. What will be the answer? Very good, Pratik. Correct answer. Answer is 3 into 10 to the power 8. Now we are coming to the electromagnetic wave theory that was given by James Clerk Maxwell in 1864. Okay, now what this electromagnetic theory says that if there is a heated object or heated rod or filament bulb, they radiate the energy, but energy emitted in form of radiations. They release the energy, but it always forms of radiations. Like radiation is like wave thing. It is not the discrete particles, it is the radiations. So energy emitted from any source, heated rod and filament of bulb continuously in form of radiation. That is what electromagnetic wave theory says. Any doubt till here? Now, what is the radiant energy? Energy emitted from any source like heated rod or filament of bulb continuously in form of radiation is called as radiant energy. Okay, heated rod or filament of bulb continuously in form of radiations. What is radiations? We will discuss in next line. Radiation is something this. Can you see the radiation? One wave is generated in the perpendicular, let's say y-x plane. One wave is generated in the y-x plane. Other wave is generated in the z-x plane. So the radiation consists of electric and magnetic field oscillating perpendicular to each other and both perpendicular to the direction of propagation of radiation. First of all, they are perpendicular to each other. So where is the direction of electromagnetic radiation? It is in the x-axis. Like the way x-axis moves, similarly electromagnetic radiation moves in that direction. So what did you understand? If there is a electromagnetic radiations, it has the two components. One is the magnetic field component, one is the electric field component. Both moves in a perpendicular direction. And movement of wave will be perpendicular to both direction. Is it clear? Movement of wave or movement of this energy, right, is in x-axis, which is perpendicular to both the loops which are forming. Is it clear? Yes or no? The radiation consists of electric and magnetic field oscillating perpendicular to each other in and both perpendicular to direction of propagation of radiation. Understood? Both. Any doubt, guys? Any doubt? So radiated position of wave character and travel with a velocity. Always remember whenever radiation emitted, in which model? Which model we are discussing? Like the Maxwell theory. So if the radiation possesses a wave character, it looks like a wave and travel with a velocity. So radiations have some velocity of light. So this you need to remember, radiations have a velocity of light. Whatever electromagnetic radiations we see, that has a speed of light. Does it require medium? Does electromagnetic radiation, what is electromagnetic radiation? Filament of bulb or heater light, whatever the energy is given, that is called as radiant energy and it is one form of radiation. Okay, then I explained the radiation. Now this statement reads like radiation possesses wave character and travel with a velocity of light. Each radiations have a wave character. It travels with a velocity of light, the way light moves with the same velocity. Okay? It does not require any medium. Fine. So radiation possesses a wave character and travel with a velocity of light. Understood? These waves do not require any material medium. Like, how can you prove? Because we get the sun rays. Right? So these waves do not require any material medium, and sun rays reaches to the surface of earth through the space, and space has vacuum in it. So if space has vacuum, this means what? Radiations are still traveling. This means radiation does not require the medium to travel. Any doubt? Any doubt? Okay, fine. This is the online class, Swara. There is no batch number here. This is the online class. Batch number is there for HSR Center class. Got it? I am moving to the next thing now. So now we will try to understand the radiations, because radiations have a wave character. Wave means you must have seen the sinusoidal wave. It looks like this. How the sine wave look like? This is the sine wave. Ting-ding, ting-ding. What? Sine wave look like this. Ting-ding, 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 ting. So it is a wave. Now we will see the property of a wave. Okay? You have a little bit idea of property of wave, but the same properties will be taught to you in physics also. So property of wave. What is the first property? Okay, it has five important characteristics. These are the main important characteristics of wave. Arthur, you have not copied the previous slide. Going very slow, write fast. Done? So here you see the main characteristic of wave is wavelength, frequency, velocity, wave number and amplitude. These are the five characteristics of wave. Means we will see if there is a wave formed, these five things are there. First is the wavelength. Can you see, guys, if wave is forming, there are trough, which is the maxima thing. Maxima thing is called as trough. This thing. This is called as crest, maxima thing. Bottom thing is called as trough. Crest and trough. Now, wavelength is the length of the wave formed. You can start from anywhere. If you start from here, one wave should form. This is over. This is the wavelength. If your wavelength starts from here, next class starts from here. This much will be the wavelength. That is length of one wave. Got it? Yes or no? So can you see that it is represented by lambda? One of the most important characteristic of a wave. This lambda representation, and A naught in meter, centimeter, or nanometer or picometer. A naught value in these four thing will work. Got it? So here you see, this is the wavelength. Any doubt? Next is frequency. What is frequency? Number of cycles of wave passed in 1 second. Very, very interesting and very, very important. In 1 second, how much waves have been passed? That is the frequency. Got it? Please write it down fast. So in 1 second, how many waves were passed is called as frequency. It is generated by nu. No, it is represented by nu. We call it as a nu. It looks like this. Nu. This one. Okay. Okay, fine. So here you have a so here you have a wave frequency. Frequency means in 1 second how many waves are being passed, and it is represented by nu. Nu is the representation for frequency and is expressed in hertz. Hz. Got it? So it is represented by hertz and it is number of cycles per unit second. So per second is the unit. Okay. So 1 hertz is 1 cycle per second. 1 hertz means 1 cycle per second. If the frequency is 5 hertz, this means 5 cycle per second. Is it clear to everyone? Yes, I am moving to the next thing. Next is relationship between. Okay, after frequency there is a velocity of wave. Velocity of wave means distance traveled by wave in 1 second. That is the velocity of wave. How much distance it will travel in 1 second? Please write it fast. Can you establish a relationship between frequency, velocity, and lambda? What is the velocity of wave? Linear distance traveled by wave in 1 second. That is the velocity of wave. Can you tell me the relationship between v velocity of wave, lambda, and frequency? Tell me fast. Very good, Prati. Correct answer. Naren, correct answer. No. 1 minute. No. Okay. So I asked the relationship between V, frequency, velocity, and lambda. So how can you do this? Okay, see. So here you have a velocity. Velocity is what? Linear distance travel in 1 second. Frequency is number of cycles per second. Lambda is length of 1 cycle. Okay, length of 1 cycle. Length of 1 cycle. Now frequency is number of cycles per second. And velocity is per second how much distance. Can I tell that? Can I say that? Lambda is 1 cycle length. Frequency means how many cycle per second. So can I say 5 lambda will be the, because they both are talking about 1 second, can I say that 5 lambda will be the velocity? Yes or no? If let's say frequency is 5 waves are passed per second, so 5 lambda means 5 lambda length have passed per second. 5 lambda length has passed per second. Isn't it a velocity only? Any doubt? Any doubt? So what is the new formula? Which for you? V is equals to mu lambda or V is equals to F lambda. Got it? Any doubt? So its velocity is represented by V is in expression centimeter per second. Meter per second. Very good, Zayan. Next. Done? So V is equals to F lambda, clear? Yes or no? I am moving to the next slide. I hope you have already copied this when I explained. Amplitude. Amplitude is the distance from the mean line at the maximum point. That is the amplitude. Any doubt, guys? You can take the mean line or and maximum or minimum anything. You will get the amplitude. Any doubt? No? I am moving to the next thing. Wave number. What is wave number? Number of wave present in a unit length. That is called as wave number. Number of waves present in unit length. Lambda was the length of one wave. So wave number will be 1 lambda. Lambda is the length of one wave. So in 1 meter, how many waves? You can again apply the unitary method. 1 lambda means length of one wave. Length of one wave. Okay, so let's say it is coming out to be 3 meter. So how many wavelengths can we are asking about wave number? So per unit length, how many waves are present? So one wave has 3 meter length. So in 1 meter, 1 by 3. In 1 meter, 1 by 3 waves are present. Got it? In one wavelength, 3 meter are present. One wavelength is like 3 meter. I'm just giving random example, okay? So 1 meter will have 1 by 3 waves. That's it. Got a simple unitary method? Yes or no? In 1 meter. So I think you understood wave number. If lambda is expressed in centimeter, mu bar will have the unit of centimeter per centimeter. Got it? Yes, no? I am moving to the next thing. Time period. Time period is one complete oscillation of wave. Time period means how much time is taken for the one wave to pass through a point. Time taken by wave to pass through one point is the time period. Like see here, time period is like how much time it is taking for one wave, entire wave to pass through. So time period is this length. So one oscillation takes how much time is the time period. Time taken by the wave to travel a distance equals to one wavelength. If c is velocity of wave, then c, okay, now c is the velocity of wave, let's say. You know what happens? We are going to discuss about, most of the time we are going to discuss about electromagnetic radiations. Electromagnetic radiations means light. So most of the time speed of light will be what? Speed of electromagnetic radiation will be what? Speed of light only. Electromagnetic radiation speed is nothing but speed of light. And that is 3 into 10 power 8 meter per second. Got it? So C is equals to lambda t. Now this is an interesting formula again. Velocity of wave. Guys, please see a very interesting formula. Speed C is the speed. C represents the speed of wave. Lambda is the distance of one wavelength. Can I say speed is nothing but distance by time? Is this the right formula? Speed is nothing but distance by time. Distance is the wavelength of one wave. Time taken by one wave. T is the time taken by one wave to travel. Understood? Or time taken by one entire wave to pass through a point. That is time period. So C is equals to lambda by T. Any doubt? Any doubt? No doubt? Next. Only Arthur and Aditya has written no doubt. Everyone else have doubt in this? Yes or no? Arey, tell me something. Do you have doubt in this? No one. If in any formula you have doubt, please ask, because in few minutes I will give you so many questions. 1 second. Hey, why you people are joining late? I already took the attendance done. You joined. You should not join late. Okay? I'm moving to the next thing. Now we will do the questions. Tell me answer of this question fast. They are asking wave number. Done? No one got the answer. Wave number they have asked. Wave number is nothing but 1 by frequency. That's it. Sorry, 1 by lambda. Calculate the lambda. Zayan got the answer. No, Zayan, not correct. Not correct answer. Think again.
So sorry, I confused it with wavelength.
Do it fast.
So where did we study the formula?
Not correct, Vishnu. Which formula? Okay,
So
Raghav.
wave number.
Huh?
So wave number formula is velocity by frequency, right?
Velocity by wave number. Wave number is 1 by lambda. 1 by lambda is, velocity is what is the frequency? Frequency into lambda is velocity. Calculate the answer. Okay, one hint. What you have taken the velocity of the particle? Velocity of wave. A red light given. Red light given. Light means speed. Light means velocity c. 3 into 10 to the power 8 you need to take. Speed of light is 3 into 10 to the power 8. Quickly answer. I think I should tell you the answer. Correct answer for this question is exact answer if you want, then answer is 1.3 into 10 to the power 6, which I think only GT Aditya got. 1.3 into 10 to the power 6. Naren got 1.05. I think it's fine only. Naren and Zayan. Ha, Pratik, yours also cool. Correct. Okay, fine. Guys, this is the solution. If you have any doubt, please ask. Lambda is equals to c by frequency. Because I told you speed of light is frequency into lambda. C is equals to f lambda. You can remember like this. F is the frequency or mu is the frequency. Or you can remember C is equals to mu lambda. Right? C is equals to mu lambda. Right? So here, okay. Now, any doubt in this? Any doubt? This is the speed of light. Any doubt? No doubt? Okay, you can remember it like this. Can you remember the name of Vimal? Vimal. Velocity is equals to m lambda. Speed is equals to m is what? Mu lambda, okay? Mu is frequency. Or you can remember VFL. Okay? So fine. Next. Next question fast. Do it fast. Last question, then we will move to the next topic. Okay, guys, you can remember it like this. CFL. This mnemonics will help. CFL. C is equals to F lambda. Will it help you now? Frequency, lambda, speed. Fine. CFL bulb. Nihal has got the answer. Nihal, correct answer. Mm, tell 4, 4, 6. Um, yes, correct answer, Naren. In 100, let me see your answer is right or wrong. 144, 144 by 100 into 60. 44 by 100, 0.44 into 60. 6 fours are 24, 24, 26. Correct answer, Vishnu. I've calculated what you have given me because you have not written in seconds. You should write in seconds. It's not like 4.44 minutes. You should write in seconds. Though your answer is right, I have calculated what you want to say. That 0.44 thing you need to convert in seconds, that it will come out to be 26 seconds. Got it? Guys, a very interesting question. No need of this frequency just to confuse you. No need to use this frequency. Distance given, speed of light is 3 into 10 to the power 8. Just, time is nothing but distance divided by speed. Simple physics question. Time is distance. 8 into 10 to the power 7 into 10 to the power 3 divided by this thing. Got it? I'm moving to the next thing. Later, more questions will be shared on the same topic. You can practice it later. Got it? Tell me answer of this fast. Okay, how was your Chem test? Anyone who got full marks in chemistry? In Chem? Anyone got full marks in chemistry? Okay. Anyone got 90%? Anyone got 80%? 70%? 60%? Okay. Aditya, tell me your rank in chemistry. Forgot everything, huh? Okay, fine. Answer of this question? Answer of this question will be A. Same thing, CFL. Speed is equals to F lambda, frequency into lambda. That's it. Got it, guys? Answer is 500 nanometer. Because the answer lambda you will get is in meter. You need to convert it into nanometer. Got it? Any doubt? No? Okay. Next is electromagnetic spectrum. What is electromagnetic spectrum? You can see what is a spectrum. Different types of electromagnetic radiations differ only in their wavelength and hence frequency. Okay, different type of electromagnetic radiations we discussed few minutes back, that radiations, white light, red light, blue light and all those things. So there are other electromagnetic radiations also. They differ only in their wavelength and hence frequency, because wavelength and frequency are inversely proportional. How? We have just now we saw C is equals to mu lambda. C is equals to mu lambda. Okay, now so one is like facing upward, one is like facing down, means okay, like so C is equals to mu lambda. Okay, fine, good, Zayan. So C is equals to F lambda. So what happened, this is fixed. If you change the frequency, lambda or wavelength of the radiations will change. So here you see there is a series of, you can see gamma, X-ray, UV, visible region, infrared, radio wave, these all are given, right? So here you have a gamma rays, this part, here you have X-rays, here you have UV rays, ultraviolet radiations, here you have a visible rays, you can see visible region, here you have infrared and radio wave. So these are the, you can see these are the electromagnetic radiations, and the wavelength increases in the order like this. Here the wavelength increases, right? So this is the increase in the wavelength. Now here you see one is the cosmic rays. Okay, now remember one thing, frequency is proportional to energy of wave. If I'm saying which is having the highest energy, which radiations, you will go with the frequency or mu. What? Mu. Mu is proportional to energy. So can you tell me which is having the highest energy out of these waves? Which is having the highest energy? Think and tell me. Very good, Naren, correct answer. GT Aditya, think again. Pratik, correct answer. Which is having the highest energy? No, I am asking in this, Nihal. Out of all these radiations, I am not asking just about the visible region. Yes? Radio, okay. Arthur, think again. Nihal, correct answer. Vishnu, think again. Guys, just remember this, just use this formula and tell me. Ritvik, correct answer. Done? Okay. So answer is cosmic rays. Answer is cosmic rays is having the highest energy. Why? Because their wavelength is minimum, and wavelength is inversely proportional to frequency. Wavelength is inversely proportional to frequency, and frequency is directly proportional to energy. This means wavelength is inversely proportional to energy. Got it? Yes or no? Any doubt? Any doubt? Okay, guys, will you remember this order? Will you be able to remember this order? Yes or no? Okay. Am I audible? So if I own one XUV, what I will say? What I will say? Gaadi XUV I meri. What? Gaadi XUV I meri. So Gaadi is what? Gamma rays. XUV is X. UV. I is infrared. Meri is radio wave. Got it? Remember like this. Next is, should I move to the next topic? Electromagnetic spectrum. What is a spectrum? The complete spectrum obtained when these electromagnetic radiations are arranged in order of their increasing lambda or decreasing frequency. The complete spectrum obtained when these electromagnetic radiations are increased in the order of their increasing lambda, wavelength increases and decreasing frequency. So that is called as electromagnetic spectrum. You can see from left to right. Here you see the wavelength is increasing from left to right. So it is the increasing wavelength, okay, and decreasing frequency. Guys, this area is nothing but visible light. Please remember the wavelength of visible light, 400 nanometer to 700 nanometer. Is it clear to everyone? 400 nanometer to 700 nanometer is visible light. Please learn this value. Visible light is VIBGYOR. So you can see VIBGYOR thing, which is having the highest energy out of violet and red thing in this entire visible region, which is having the highest energy, violet. Okay, very good. Guys, any doubt in this? Please remember the wavelength. Any doubt? Yes, no? I'm moving to the next thing. Let's have a quiz. Tell me answer of this fast. Fast, fast, fast. Fast, 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 fast. That is I think current carrying solenoid will produce the radiation, that field, that is electromagnetic field. That is different thing. That is magnetic field will be generated, if I remember it right. Understood, Raj? You will learn in physics in detail. If you really ask me, I forgot about solenoid, but I learned in my 11th, 12th. So there it produces the magnetic field, I guess. Got it? But that is different from electromagnetic radiations. Okay, answer is, have you got the answer, guys? Vishnu correct answer, Saket correct, Naren correct. Zayan, think again. Raj Venkat correct. GT Aditya, think again. Omkar, zero participation as of now. Ritvik, Swara. Swara, how there are two Swara and Swara Premanand? Are you two different Swara or logged in from two devices? Oh, Advay. So Advay, why you have not logged in by your ID? Hey, change your name, then how I will put in attendance? Change it, change it. Okay. So I will tell you the answer. Answer is A. Any doubt, guys? Same thing. Repetition. Any doubt? Any doubt? No? So whatever we have discussed is written here. observation, Rutherford model. So this is the summary which we discussed. Okay. Fine. I'm moving to the next part. So just give me 1 second.
So could you explain the solution for that problem again, sir?
What?
So for the problem that I got wrong, I'm still not able to figure out
Which problem
where
you
I've
got
gone
wrong?
So that time you told me to think again. So just now in the quiz problem.
Which problem? This problem. This one.
So yeah, this one.
So just calculate the wavelength. If it
So I got
wavelength,
10 to the power minus 5 meter approximately.
how? So meter converted into nanometer.
That will become 10 to the power 4 nanometer.
So convert it into nanometer. Whatever you are getting, it will come under the range of visible region. 1 minute, I'll show you. Where is 1 minute? 1 minute, 1 minute. See, it comes under the visible region now. 649 nanometer. Come under the visible region. What is the range? 400 to 700 nanometer is visible region. So whatever comes under this range will be a visible light if wavelength comes under this range.
Yes, sir. Thank
If
you.
wavelength comes under this range, it is visible light. Got it? Got it?
Yes, sir. Yes, sir. Thank you, sir.
I am moving
Yes,
to the
sir.
next thing.
Exponent data.
Okay, I am moving to the next part now. Here. Okay, guys. Now the next is electromagnetic wave theory is over. Now here you see this is the foot. Now the point is we have discussed about the electromagnetic radiations. Now electromagnetic radiations, you know, there is a failure of Maxwell's theory. What's the failure? He said that electromagnetic wave is means electromagnetic wave theory was successful in explaining the properties of light like interference and diffraction. What he said? He said that all the electromagnetic radiations are wave type of having wave nature. He said that electromagnetic radiations have a wave nature. For electromagnetic radiations have wave nature, these two properties can be explained by that. These two properties of the light, you will learn in physics, these two properties two properties of light can be explained by the wave nature of light. One is what? Interference. When you put the two slits here, a double slit experiment, and one light is being passed, you will see this type of pattern is observed. This can be only explained with the help of wave theory, that light is a wave. That is why it will happen. Similarly, the diffraction pattern, you see these are the light is going and there is a one slit, so you will get this type of diffraction pattern. So that is only be explained with the wave. Because light is a wave, it can generate the diffraction pattern like this. So these two successfully explains the Maxwell theory of electromagnetic radiations as wave. But there are two more theories which cannot be explained by electromagnetic radiation, cannot be explained by wave theory. What are those two things? I will tell you. One is he failed to explain the black body radiation. Wait, Swara, don't come to conclusion. So here he failed to explain the black body radiation. How the black body radiation behaves and how it is, how it shows the radiations and all. He could not explain with the wave theory of light. He could not explain this with wave theory of light. And second is, please keep on writing, he failed to explain the phenomena of black body radiation. Right? And second phenomena, what was the thing? He failed to explain the photoelectric effect. What is photoelectric effect? I'll tell you in short. if light falls on any metal surface, if any light falls on any metal surface, electron from the metal surface will be ejected. What does this mean? Here light falls on this metal surface, it will give energy to the electron, electron will be thrown away, will be ejected. This is called as photoelectric effect. Is it clear? Light wave strikes here, electron will gain the energy due to this light wave energy, this will be ejected. That is also not been explained by the wave theory, because waves, like how waves are ejecting the electron, that can't be explained. So in these two cases his theory failed. Okay, what else other than this? What other than this? The variation of heat capacity of solid as a function of temperature. Like heat capacity, we will discuss this in thermodynamics in detail, but heat capacities are like molar heat capacity or specific heat capacity. These type of heat capacities are there. It is like how much heat is given to increase the temperature of 1 mole of substance by 1 degree Celsius. How much heat is required, that is its heat capacity. So how the heat capacity of solid as a function of temperature means it is a hot here, it is a not hot. If you have this, you can see here thermal when held in the hand. So what will happen? Thermal conductivity is large here, but thermal conductivity will be small for the hot object. Okay, why it is like this? We will again, this is not been explained by Maxwell wave theory. Okay, then next is the last one is the line spectra of atoms. Line spectra of atoms with special reference to hydrogen. He could not explain line spectra of atoms with special reference to hydrogen. So here you see the absorption spectrum of hydrogen and emission spectrum of hydrogen. These both you can see here a continuous, you can see colored thing, continuous colored thing, but there are just black, very few black lines. He could not explain why there is a black lines with the wave theory. With the wave theory of electromagnetic radiation, he could not explain why the absorption spectrum of hydrogen, means rays absorbed by hydrogen, gives this pattern. Why the rays emitted by the hydrogen gives this pattern. Very few colored lines. Very few colored lines, rest is completely black. So these four things could not be explained with the help of wave theory of Maxwell. So this phenomena could not be explained if electromagnetic waves are supposed to. So how they will explain? That will only be explained, these four phenomena, if electromagnetic waves are supposed to be particle nature. Means if you assume their wave nature, you can't explain this four phenomena. But if you assume its particle nature, you can explain this four phenomena. Is it clear to everyone?
So yeah, both waves and particles at the same time, right?
That we will come to that later. This topic, like whether they are same or different, we will come to that. Understood?
So in this topic itself, we'll be learning that.
In this topic, after this topic.
So
Okay. Few things can be explained by wave nature, few things can be explained by particle nature. So the final conclusion will be it has a wave as well as particle nature. Understood? It will have wave as well as particle nature.
yes.
Okay, please, have you copied this? Could I move to next slide? Could I move to next slide? Or do you want break now? What do you say? Fast. Okay, I'm getting more break thing. Fine, we will have a break of 15 minutes now. So have you copied this? Yes. It's 52. We will have a break till 7. We will have break till 7:07. Fine. Okay. No, no. 7:07. Okay. Guys, audible. Guys, audible. Okay. Have you written this? Let us start with the black body radiation. Now, guys, one thing is clear that light has dual nature. It is neither have means not just particle, not just wave. It has a dual nature. So what we understood, electromagnetic